Okay, so what we're going to do in this video is we're going to have a look at how we can use chi-squared as a test to see if our genetic outcomes, our crosses and our ratios, are showing us what we'd expect to see. Okay? Normally when you're doing chi-squared, you're looking for a difference. Okay? And that difference is in between frequencies. All right, and normally when you're doing a chi-squared test, you want to find a difference. You want to be able to reject your null hypothesis because what you found is significantly different from what our expected values would give us. Okay, here's how it's different when we're doing it in genetics. We want to find that our ratios that we've got in our experiment match the ratios that we'd expect if Mendelian genetics is correct, which it is. So we want to find the same ratios as Mendel. We don't actually want to find a difference. We want to find that there's no difference, okay? So in effect, if you had a null hypothesis for this, you'd want to be accepting your null hypothesis. You'd want to go, my ratios in between my numbers are so close to what Mendel said I would get that I can say there is no significant difference. So in every other type of chi-squared, you want to find the difference. You want to be able to reject your null hypothesis and find there's a significant difference. Here, we don't. We want to find no significant difference. So what I've done is I've collected some data up. Okay, I've made some data up of what I would expect to find if we sampled the whole school population of pupils. So around just under 1,000 pupils in all years from 7 to 13 and find out whether their earlobes are detached or attached. Okay, so again, remember that's where your earlobes meet your head. Do they go straight in or do they dangle and come back up before they go straight into your head? Okay, now we know that this is a recessive characteristic and this is the dominant trait. Okay, so we'd expect to find more people across the school have detached earlobes than attached earlobes. If you sample any class, I do this regularly with year 11 almost every year, it's nearly always comes out approximately what I would expect. But I've not done any stats on it. I haven't tested it using chi-squared. I don't know if the difference I'm finding is too big a difference to say this is like what Mendel said would happen, okay? Mendel says you'd expect to find a 3-to-1 ratio, okay? So he would expect to find a 3-to-1 ratio between detached earlobes and attached earlobes. So what we need to do is this. Obviously, we start out the same as normal. You get your sum, which is your total of the observed data. So this is all the pupils who've got detached earlobes and all the pupils who've got attached earlobes, and that comes to 979. Now what you'd normally do in a normal chi-squared is you'd say, well, I'd expect them to be split evenly between my two categories, but we don't expect to find an even split. We expect to find a 3-to-1 ratio split. Let me just move that up a touch. We're expecting to find a ratio of 3-to-1. So actually we need to split them according to what we'd expect. 3 in here for every one that's in here. So I have done my 974 and I've divided it by 4 because that's 3 and 1 together, isn't it? And it gives me 244.75. Okay, so I'd expect 244.75 pupils to have attached earlobes, and then I'm going to expect to find the rest, which is 734.25 will have detached earlobes. Okay? And again, that's going to add up to 979. So can you see the big difference here with what I've done is that instead of splitting between the expected evenly and splitting them exactly in half, I've not split my 979 in half. I'm not putting, 438, 439 pupils in each of these two categories. I'm putting 734.25 in here, which is 3/4 of them, and I'm putting the other quarter in here because that's what my ratio says I would expect if Mendel is right. The rest of the chi-squared test is normal. I have never ever ever seen anybody ask on a A-level exam for anybody to do anything beyond this at this point. But I have seen them give these two sets of data and seen them expect you to total up here and divide it according to the ratio you'd expect to find. This is the bit you get your marks for, okay? Knowing that the expected and the observed have to add up to the same. They've both got to be 979, but that if you're doing it in genetics, the ratio of your split in your expected is not the same as the ratio you'd expect to find otherwise, okay? And what you'd hope to find is that 734.25 is close enough to 720, and 244.75 is close enough to 279 that when you look at your table of critical values, and remember we'd be looking for p equals 0.05, and we'd only be looking for 1 degree of freedom because we've only got 2 categories, that we'd find that our chi-squared value doesn't exceed our critical value. We don't want to exceed it this time, do we? We want to find that our data is too similar for there to be a significant difference. So when you're looking at it from a genetics point of view, you do the same process, you split according to the ratio you'd want to see, but you want to find that your data is not significantly different. That's what you're hoping for, okay? So I'm going to pause this, rub this out and do a slightly more complicated version, and we'll have a look at that before we finish. Okay, so what I've done here is I've done an example with Mendel's peas, which we know can be yellow or green, and they can be smooth. And I forgot to put in the other video that sometimes they don't call it smooth, they call it round as opposed to wrinkled. They always say wrinkled, but sometimes smooth is round. It's fine, as long as you know it's the same thing. So you could have a yellow and smooth pea, you could have a yellow and wrinkled pea, you could have a green and smooth pea, or a green and wrinkled pea. And what we need to do is we need to then have a go at doing this. So what I want